Alright, so here we will be understanding the Fibonacci sequence, okay, and I don't really care about the pronunciation, okay. So first let us understand what exactly it is. So here, Fibonacci sequence is a series of numbers where each number is the sum of two preceding. This is a series of numbers where each number is a sum of two of its preceding ones. Alright, and one more thing to note here is that starting from 0 and 1, you will know later in this video. So what we are going to do is that we will be solving this through recursion only, so that you can understand recursion much better. Okay. The steps will be, first, if the number is 0 or 1, then return the number itself, or return the sum of the Fibonacci sequence of n minus 1 and n minus 2, sum of its two preceding ones, okay, because n is the correct number. These are the steps, that's it. And here the time complexity is O2 to the power n, 2 to the power n, alright. Because there are so many redundant calculations, that's why. It can be optimized by using like other methods, but for now we'll be studying recursion only. Okay, optimization we'll be studying later on. The space complexity will be O of n, okay, because of recursive constant. Now it's time to write some code. Function Fibonacci, alright, here n will be a number, this will return a number, okay. I'm not interested in update. And here, if n is less than equals to 1, return n, else Fibonacci n minus 1 n minus 2. Alright, now let's call it. Let's say 9. I think this will be like very large. No, okay. Yeah, it's 34. But as you increase the number, it becomes larger and larger. See, 4181, and if I make it 119, just look at the amount of time it is taking. Just look at this. It has still not solved. Okay, it's calculating, it is calculating, it is calculating, and I just cut it down because I'm not interested. What if it was 39? Look at this number. 39 itself is this. Imagine how much was 119. Okay. So here what happens is that, you see, first we have a recursive function. Here we have a base case setup already. Now n is a number. Let's say we added let's say 4. Okay. Now the answer is 3. So here this is 4, not less than equal to 1, and 4 minus 1 plus 4 minus 2, 1 plus 2, 3. Okay, like this. It will keep on calculating, it will keep on calculating, and that is how. Okay, 4 minus 1, 3, and then 4 minus 2 again. So 4 minus 3, so 3 minus 1, and then this 3 minus 2, like this. It will go. Okay, that is how it works. So this is a very naive recursive implementation, and this is it in the recursion. Now next we are going to study the backtracking in the upcoming videos. Thank you.